All right, this massive list finally finished being entered in memory. But remember our key terms. Remember how I said a list is an iterable? What was an iterable? Well, an iterable is any object in Python which we're able to loop through. Underneath the hood, it has the dunder iter method. So when the object is created, this iter allows us to have an iterable object that can be iterated over. To iterate something, or iteration, is the act of taking an item from an iterable, doing something to it, then going to the next one. When we use loops, like for loops or while loops, we call that iteration. It's the process itself. And generators are actually iterable. That is, everything that is a generator is iterable. You can iterate over them. But not everything that is iterable is a generator. For example, a range is a generator. So that is always going to be iterable. But a list is an iterable, but it's not a generator. So a generator is a subset of an iterable. I know those are a lot of words. Hopefully you're still with me. The difference between a generator and a regular iterable is the way we implement them. So let me show you a general way to create a generator. Let's clear this code and define our own generator. And generators are usually functions. Just like range is a function, generators are usually created this way. So let's say generator function. And this generator function is going to have a for loop that is going to loop over a range, just like we had before. But the difference here, let's actually bring back the code that we had previously. Just going to comment this out so we can see it in terms of difference. The generator function is going to create, let's say, these many items. But instead of returning like we would in a regular function, we're going to use a keyword called yield. And here, we're going to yield the I, so the item. So notice the difference here. Now, if we want, just like here, we can pass a number like this. But instead of returning and appending this list and creating all this data, we're going to use yield. Now, what does yield do? You see, yield pauses the function and comes back to it when we do something to it, which is called next, something that we'll cover shortly. So yield says, hey, pause the function, just yield I, give I, and when you tell me to keep going again, then I'll keep going. So how can we do this? Well, I can say for item in the generator function, I'm going to print the item. Now here, what's going to happen is we're going to loop over the generator function, and we'll give it to the generator function, let's say 1,000 for now. And we're going to print each item. In the generator function, because this is an iterable, it's going to run and it's going to loop. And for every item in this number, so that is range, we're going to yield y. So it's going to keep looping and looping. And when we come back, when we loop over, we're going to run this. And the yield comes back and runs again. Let me show you what I mean. I'm going to comment this out as well, and just click run here. Did you see that? What we just did here is similar to down here, but instead of having to create that list in memory, it just kept going one by one. We only held one item in memory. and we used it however we wanted to. In our case, all we did was print item. Let's explore this yield keyword a little bit more. What does it actually do? Let's say that we want to multiply this by 2, just like we did here in our original example with lists. But now, instead of doing the for loop, let's just call the function and say g equals generator function, and we're going to give it 100. Now, if I print g and I click run, you see that I get a generator object. And remember, this is just the standard way in Python that we can create a generator function using the range and the yield keyword. But this yield keyword gives us some power, because if I just return here, we're not going to get anything special. As a matter of fact, we're just going to get a value. Instead, by using the yield keyword, what we're able to do is to turn this into a generator function that can do, well, this. I can say next g. Now, if I print next g in here and I click run, I get 0. But here's the cool part. If I do next g twice and then one time here and print it, I get 4. Why is that? Remember, the yield keyword pauses the function. So what just happened here is I ran the function with 100. The first item in range 100 was 0. Right? Now here, before I was even able to run this, it said, hey, this is a generator function. But the first time you run it, give the output 0 times 2. So that the very first time we run this function, and I click run, oh, make sure we change that to I. This is just 0. If I run it again, like this, then we have, now I want you to iterate and go to 1. So 1 times 2, what is that? Well, 1 times 2, let me fix that like this. Make sure this is I get 2, because 1 times 2 is 2. If I run it again, and I click run, I get 4. You see, yield, like I said before, pauses the function and comes back to it when next is called. So if it has a yield keyword, it becomes a generator. It keeps track of this state, what we call the value, and it only keeps the most recent data in memory. For example, 4. It remembers that because on, let's say, line 14, if I do print next g, it remembers that previously this I was, well, 4. So now, even though this piece of code already ran, if I run it on line 14, I get 6. Because 3 times 2, well, is 6. Remember, because it gets multiplied by 2. So let me ask you this. If, let's say, I only do a range of 1 here, and you know what, let's just remove multiply by 2. If I do this and I run next more than once, what is going to happen? If I click run here, I get a stop iteration. You see, next can be called as many times as we want, as many times until this range expires. And when we exceed the number of items in the range, well, we get a stop iteration error to let us know that, hey, you can't call next anymore. We've reached the end of line. And when we use for loops with ranges, it actually detects this underneath the hood for you. So we're able to run a function like this where we use range, even though range is a generator, because the for loop automatically says, hey, I'm going to stop looping as soon as I encounter this stop iteration. But that's hidden away from us as users. Now, this concept of generators is pretty hard to understand, especially at first. So you might have to look at this a couple of times. But over the next couple of videos, I want to convince you how powerful they are. I'll see you in the next one.